Assalamu alaikum and good day to all of you, my dear students. This is video 1 about scalar product, chapter 10 in our textbook. In this tutorial, we will discuss definition of scalar product, sign of scalar product, finally, scalar product and orthogonal projection. Before we start our discussion, I would like to remind you that two non-zero vectors u and v are equal if we can say that they have same direction, same sense, and same magnitude, and they are collinear if we can write the vector equation u vector equals a constant by a vector v, where this constant is a real number. Okay, and we almost forgot about our friend Mr. Yang. Mr. Yang wants a favor from us. Would you care to help him? Good. Mr. Yang wants to calculate the exact value of the angle theta formed between the trajectory of the racing car and his drone, given their equations. Can you help him? Okay. Were you able to help him? Never mind. Scalar product to the rescue. Well, definition. Geometric form. If u and v are any two vectors, then the scalar or dot product of any two vectors u and v is given by u dot v, yes, u dot v is equal to the norm of the vectors u and v multiplied by the cosine of the angle between them. Application. To practice the above formula, I would like you to stop the video, grab a pen and a paper to calculate the dot product of the vectors u and v in each of the following cases. Solution. At this stage, it's good to ask yourself, is dot product a scalar quantity or a vector quantity? Excellent job. From the above examples, you can see that it's a scalar quantity. That is to say, it's nothing but a real number. Sign of dot product. In this part, we will study the effect of the angle between the two vectors on the sign of the dot product. If angle is acute, then dot product is positive. If angle is obtuse, then dot product is negative. Now for the special cases, what happens if the angle between the two vectors reduces to 0? The sign of the dot product is still positive, but the dot product would be equal to the norm of the first vector multiplied by the norm of the second vector. What happens if the angle between them is 180 degrees? The dot product is negative, but the dot product is the opposite of the norms of the two vectors. Now what happens if the angle between the two non-zero vectors u and v is 90? If the angle is 90, then the dot product of u and v is 0. And in this case, we say that the two non-zero vectors are orthogonal. Now, can the dot product between the two vectors be 0 other than if the angle is 90? Yes. If one of the vectors is 0, then the dot product of the two vectors is 0. So pay attention. Dot product is 0 doesn't mean that the vectors are orthogonal, only if they are non-zero vectors. Now, as a summary of what we have found, we can say if alpha is equal to 0, then dot product is equal to the product of the norms of the vectors. If alpha is acute, then dot product is positive. If alpha is 90, then dot product is 0. If alpha is obtuse, then dot product is negative. Finally, if alpha equals 180 degrees, then dot product is the opposite of the product of the norms. Now please, my dear students, snapshot this frame to keep it as a reference. As a consequence, the dot product of two vectors u and v is 0 if one of the two vectors is 0 or the angle between the two vectors is right. Now notice two vectors are orthogonal if and only if u and v are non-zero vectors and u dot v equals 0. Now we already found that the dot product between two vectors is equal to the product of their magnitudes by the cosine of the angle between them. But what happens if we can't find the norm of one of the two vectors, in particular here AC? What can we do? Okay, now to do this, we can think about AC as sum of two vectors, one in the direction of A, B, and the other is perpendicular to AB. Now the dot product would be equals AB dot AH plus HC. But AB and HC are orthogonal and the dot product is equal to 0. In this case, we will have AB dot AC will be equal to AB dot AH. As a summary of what we found, we can see that the dot product between any two vectors AB and AR is equal to the dot product of AB by the orthogonal projection of vector AR on the direction of AB. Application: if ABCD is a rectangle of dimensions 6 and 3 units, I is the midpoint of segment DC, then calculate the following dot products. Stop the video and calculate them, please. Use a pen and a paper. Notice that vectors AD and AB are perpendicular. Also, DC and DA are perpendicular. Now you try assignment. Don't forget about Mr. Yang.